Hi everyone, thank you for joining. In this video we're going to prove sine x plus y is equal to sine x cos y plus cos x sine y for xy is less than pi. Now in this diagram we have a circle and this is the center of the circle O here. And the radius of the circle is r, and we have a triangle and another right angle triangle inside that triangle, right? Now first thing to do is to notice that this angle here will also be z. And where does that come from? Well, that comes from circle theorems at GCSE level. So if we simply connect this side to that side, and what we have here is that we have this shape here, and if you're familiar with the circle theorems, that you will immediately see that the angle here must be twice the angle there. And since this is an isosceles triangle, this is also r, right? Z and Z. So we split 2Z into Z and Z, right? Because it's an isosceles triangle. Since we've established that the angle at O is Z, we can now move on and notice that we have sine Z, looking at the right angle triangle here, is opposite over hypotenuse, so that's equal to C over 2R. And using the sine rule, we have sine Z over C is equal to sine X over A, which is equal to sine Y over B. In other words, if we sub that in here, we will have 1 over 2R is equal to sine X over A, which is equal to sine Y over B. And we can write it as 2R is equal to A over sine X, which is equal to B over sine Y. Now I'm going to make sine x and sine y the subject because we're going to use it in a moment. So sine x is equal to a over 2r and sine y is equal to b over 2r. So I'm going to put this in a box because we're going to use it in a moment, and let's name it as 1. Now looking at the bigger triangle, we have sine z, which is equal to sine pi minus x plus y. So we're saying this angle is equal to 180, take away the sum of the other two angles. And if we use the sine expansion, that will give us sine pi cos x plus y minus cos pi sine x plus y, right? But sine pi is 0 and cos pi is minus 1. That means this will equal to sine z is equal to sine x plus y. But looking at this bigger triangle again, and if we drop a perpendicular from there to there, we will have C, the length C, will be sum of these two lengths, so that plus that, right? So the highlighted length is simply A cos Y, and this length here will be B cos X, right? So let's put this in a box as well. And we also have from this equation, we have C is equal to 2R sine Z, right? And if we combine this with that, we can rewrite this equation here as 2R sine Z, that's C, is equal to A cos Y plus B cos X, right? In other words, sine Z is equal to A over 2R cos Y plus B over 2R cos x. We've divided both sides by 2r. Now if we look at here, we know that a over 2r is sine x, so we have sine z is equal to, we know that a over 2r is sine x, and if we simply plug that in there and plug b over 2r here, we will have sine z is sine x cos y plus sine y cos x, right? But we know that sine z is equal to sine x plus y. That means we have sine x plus y is equal to sine x cos y plus cos x sine y. And this is what we wanted to prove. Yeah. Well, I hope you found it interesting. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.